VIT, a place to learn, a chance to grow.
Hello everyone, this is Jagannath Pandyan from the School of Electrical Engineering. It's a pleasure to present you this short lecture series on process dynamics and control. I'll be using MATLAB and Simulink for demonstrating some of the concepts. And I have given you the books referred in this course towards the end of this video. And if there is any corrections or if there is some clarifications in the video, please mail me. Let's go to the course. Let us start the course with some introduction. If you take any industry, the overall objective will be to convert some raw material into desired product, like wood to pencil, or limestone to cement, or extraction of sugar from sugarcane, and many more examples one could come across. So if you ask what constitutes these plants, then the answer is arrangement of one or more processing units. For example, it could be reactors, heat exchangers, distillation columns, boilers, and many more. Fine. For successful operation, a plant must satisfy several requirements. These could be imposed by the designers or the influence in the plant environment. First, we have to make sure the plant environment is safe to work with. Then, we have to meet the product specification in terms of quality as well as quantity. Then we have to satisfy the environmental regulations according to the law. We saw a plant has lots of equipments, each will have their own operating constraints, and we have to make sure it is not violated. Finally, when the plant is running, the designed system should effectively utilize all the resources. Now, the needs process control or the control system has to satisfy will fall under one of the following classes. 1. With the help of control system, we can suppress the influence of disturbances which is caused by the external world on the process. Stabilizing the process. When the process is unstable and has no self-regulating nature, it is necessary to have an external controller to stabilize it. Third, after achieving safety and product specification, the next objective will be to improve the profit. For this purpose, it is necessary to dynamically operate the plant. For example, it could be the flow rate, chemical concentrations, or temperature of the units. So, a control system is necessary to operate the process dynamically and maximize the economic objective. Now we'll see the variables involved in a process. There are input variables, first the manipulated variables, which are freely adjustable by human operator or by a control mechanism. Then we have measured disturbances, which are again input to the process coming from the external world. And there are unmeasurable disturbances also. Then coming to the output side, there are measurable outputs and also there are unmeasurable outputs. Now we'll see a typical process control loop or the closed loop system. Now we have a process, and in the process we have variable to be controlled with the help of some manipulated variables, And if we are trying to control some variable, we have to design some sensors. So we have sensing elements with necessary signal conditioning, and this path is forming the feedback path. So this path is also the feedback path, and we have a set point or desired level for that variable to be controlled, and this desired level is compared with the actual. Then the difference is given to the controller, and the controller will actuate some final control element, and that final control element will change our manipulated variable. So this is a typical process control loop. Now, with the help of this example, we will see the hardware elements involved in a feedback control system. One could observe there are two independent control loops present in this example. There is a level control loop and there is a temperature control loop. So in the level control loop, level is your process variable or variable under control, and this level is being measured with the help of a differential pressure cell, and the measured level is recorded as well as it is being sent to a controller, and the controller is receiving the set point for the level parameter or the desired level for the level, and this controller is taking action on the final control element, which is a control valve here, and this control valve is controlling the outlet flow from the process. And if you take the level temperature control, here we are using a thermocouple to measure the temperature, and this temperature is being given to a controller, and the controller is receiving the desired temperature, and based on the difference the controller is taking action on a final control element, which is again a control valve here, but this control valve is controlling the flow rate of a coolant which is going across a heat exchanger present inside the process. And these are the references used for this course. Thank you.